Welcome to Gifted Dance Science and Technology Physics class. I'm NC Joshua. We'll be looking at equations of a progressive wave today, and the equation on the board is a generalized equation for a progressive wave, where y is the displacement of the wave is equal to a sine, the a here is the amplitude, sine open bracket wt plus or minus ks. The plus or minus determine the direction of the wave. So when it's going towards the right, we use the negative sign, and when it's going towards the left, we use the positive sign. Now each of these factors have what they stand for. The W is the angular frequency, the T is the time. Remember, the A is the amplitude maximum displacement, the K is the wave number, and the X is the position. Now, remember that angular frequency is equal to 2 pi f. So, this place Wt can be 2 pi ft. Now also, wave number here, k, is equal to 2 pi over lambda. So therefore, kx, which is equal to phase angle or phase difference, is equal to 2 pi over lambda dot x. So we have kx is equal to 2 pi over lambda x. Then we have our w to be equals 2 pi. So generally, if I'm writing the equation of wave, I will have y is equal to a sine open bracket. In place of angular frequency, I'll be using 2 pi ft. That's this now. 2 pi ft plus or minus, in place of k, I'll be using 2 pi over lambda x. So to take the common factor, which is your 2 pi, we'll be having y is equal to a sine, bringing out the common factor, which is 2 pi, open bracket, I have ft plus or minus x over lambda. So this is another equation derived from this equation. Now we can see progress if f as frequency equals 1 over period. If f as frequency equals 1 over period, therefore I can have y is equal to a sine open 2 pi open bracket. I have now f will now be 1 over t dot t plus or minus x over lambda, close the bracket. So our formula will now be y is equal to a sine 2 pi open bracket t over t plus or minus x over lambda. Now if I am giving this as my equation 1, I'll give this as my equation 2. Then it means I'm giving this as my equation 3. Then I can also get another equation from here. How? I know very well that if V equals F lambda, therefore replacing F, I will now have F is equals V over lambda. So I want to put F equals V over lambda into equation 2. I will now be having y is equals a sine 2 pi open bracket. In place of v, in place of f, I'll be having v over lambda v over lambda. There's a t. In place of f, I'm having v over lambda. There is a t plus or minus x over lambda. This is another equation, and we can call that equation 4. So we have 4 equations derived from this main equation, and the first one is, what did we do? Is to substitute 2 pi f in place of w, and to substitute 2 pi over lambda in place of k. Remember, k is our wave number and w is our angular frequency. In doing that, we arrived here. Bringing out a common factor, which is 2 pi, we arrived here. From here, we now said, let our f be reciprocal of period. So 1 over period, 1 over time equals f. So in the next formula, f is substituted for 1 over t. So we have 1 over t dot small t plus or minus x over lambda. That gave us this. Then from this same formula again, what we did is now to substitute f in for, we substitute f, putting in v over lambda. And so we have here, removing f as v over lambda dot t, that's v over lambda times time, that times t, which is your time, plus or minus x over lambda. Now the next stage is to use all of this equation to see how questions are being asked. Now let's look at example 1 as regards using wave equation to answer questions. The question says a plane progressive wave is given by the equation y equals 0.5 sine open bracket 100 pi t minus 10 pi x over 18. Now, to solve this question, we're going to ask which of the equation of wave can be used to solve this question. Now, remember that y is equal to a sine open bracket wt plus or minus kx. Remember, w is 2 pi f, 2 pi f. So y is equal to a sine open bracket 2 pi f, then t plus or minus k is 2 pi over lambda, then x, close the bracket. So I'll be using this equation to solve this equation to compare with this to solve my question. Now, question number 1 says, what is the maximum displacement? Maximum displacement is amplitude. Therefore, you compare. So comparing with, what are we comparing with? Y is equal 0.5 sine open bracket 100 pi t minus 10 pi x over 18. So now it means my 0.5 here is my A here. So my maximum displacement is equal 0.5 meters. Very simple. Remember, maximum displacement is also called amplitude. The next question says intensity. What is intensity? Number 2 says intensity. Intensity is amplitude squared. So number 2, which is intensity, is a squared, which is equal to 0.5 squared, which is 0.25 meters squared. That is the answer to intensity. What is our question number 3? Question number 3 says, find the frequency. To solve for frequency, I'll ask myself, in the main equation, this is where frequency is found. So I will compare it to where I think frequency can be found in the equation given. So I'm comparing this with this. So it means my question number 3 will be solved as 2 pi ft is equal to 100 pi t. I compared where I have frequency with where frequency ought to be in the given equation. So my t takes off my t, my pi takes off my pi, 2 takes off this, I have 50. So frequency is equals 50 hertz. That's the answer to question number 3. What about question number 4? Wavelength. The same approach. I'm going to look at where I have wavelength in the equation and compare with where wavelength ought to be. I will not say wavelength equals 18. No, I will compare to solve. And how would that be? Number 4, I will say using 2 pi, comparing 2 pi x over lambda is equal to, this is what is equal to. These are the sides I'm comparing, is equal to 10 pi x over 18. X cancels out X, pi takes off pi, and I have lambda is equal to 2 times 18 over 10. 2 times 18 over 10, which is equal to 36 over 10, which is 3.6 meters. You see, the right answer is 3.6 meter and not 18. You would have just said, since here is lambda, then the answer should be 18. No, you have to equate it to solve. What about the last question? The last question said we should look at for the wave speed. Now remember, there's an equation that has frequency, wave speed, and wavelength, which is V is equal to F lambda. This equation will be used to solve for our wave speed. Now we already have our frequency, which is 50 hertz, 50 multiplied by a wavelength, which is 3.6. So that becomes V is equal to 36. 36 times 5, V is equal to 0. Then this becomes 15, that's 180 meter per second. Alternatively, I can say V is equal to W over K. Take note of this, very important. Wave speed is equals angular frequency over wave number. Question, where is my angular frequency and where is my wave number? Remember, this is my angular frequency, this is my wave number. This became this, and this became this. Now, if you come over here, you now realize that this is W because it is always WT. This is W and this is my K because it's always KX. So there's an X, there's X here. So this is K and this is W. So now, what will I do? I will come over here to say wave speed is equal to, remember, what's my W? Is 100 pi, that's my W, divide, what is my K? My K is 10 pi over 18. So V is equal to 100 pi times 18 over 10 pi. This takes off this takes off this. Then we have V is equal to 180 meter per second.
Now looking at another example, now if you check the equation as compared to the first example, it's a different equation. And so most times many persons feel that I have to learn all the different equations, but sometimes it's not actually true. You can actually use the same equation to solve this. I will show it to you. Now remember, the equation that looks exactly like this would have been this one. Y is equal to, I will reiterate again, a sine open bracket 2 pi ft plus or minus 2 pi x over lambda. Now this is the equation. Now bringing out your 2 pi out, you have y is equal to a sine 2 pi ft plus or minus x over lambda. Now, converting your f to 1 over t, will now be having y is equal to a sine 2 pi open bracket. We'll have this as t over t plus or minus x over lambda. So, originally, this equation looks like what the question here is given. So, compare with what I'm comparing with y is equal to 0.2 sine pi open bracket t over 0.1 plus x over 0.2. Now it means if you are to compare, it means I have to compare everything. The pi here will multiply this and multiply this. So if you relate of having y is equal to 0.2 sine open bracket, it becomes pi t over 0.1 plus pi x over 0.2. So that means this, just as this 2 pi, we multiply everything here to become 2 pi t plus or minus 2 pi x over lambda. So now let's see our question, how it was asked. The question was asked that we should calculate maximum displacement. And remember, maximum displacement is our amplitude. So if you check, our A here is equal to 0.2. So our maximum displacement is 0.2. Now also, my next question says, calculate the frequency. Still very simple. Frequency always goes with t. So I am comparing this with this. But for this case, this does not look alike. So I'm comparing this with this. So therefore, I'm solving now saying that 2 pi t over bt is equal to pi, not 2 pi, pi t over 0.1. I repeat, I'm not comparing this with this because this and this look alike. Although I can solve it with this, I will show it to you in a moment. Now I'm comparing this with this. So now this is the standard. 2 pi t over pt, which is this, is now equal to pi t over 0.1. So if this takes out this and pi takes out pi, I will have my period is equal to 0.2 seconds. That becomes my period. Although our question did not ask us to calculate for period, but I have to show you this is our period. Why? Because from here, I can get my frequency. From my period, I can get my frequency. So frequency is equals 1 over t, which equals 1 over 0.2. So our answer now is frequency is equals 5 Hz. Now, if I have frequency as 5 Hz, the next question says calculate wavelength. Now, to get wavelength, it means I'll be comparing here with here. Now, remember, this 2 pi will multiply x also because it's outside the bracket. So it will multiply x just as it was used to multiply t to get 2 pi t. So also it will multiply x to get for us to have 2 pi x. So to get wavelength, now I'm solving for number 3. I will now be having I'll be having my 2 pi x over lambda is equal to, what is it equal to? Is what is equal to? Is equal to pi x over 0.2. Now x will take out x, pi will take out pi. What becomes our wavelength? Our wavelength is now equal to 0.4 meters. So if you see, we have solved for frequency. We got that by knowing our period, and also we have solved for wavelength. It is wrong to just assume that since we have arrived here, to just assume that our period is 0.1. It will be a wrong answer if you just say since this place is our t, since here is t, therefore our period is 0.1. It will be a wrong step because what was given outside was not 2 pi. If what was given outside was 2 pi, it would have been equal to what we have at the denominator level. But because it was pi, we had to solve it out to show. Likewise, it would be wrong to assume that our wavelength is equal to 0.2. No, because what was given out was not 2 pi, was pi. If it was 2 pi, both sides would have been equivalent to what we have as in these denominations. So what we have shown is that we can use this formula to solve out equations like this. Now I want to show you that I can still use this formula to solve this equation. It can still be solved. It's just to equate 2 pi ft to pi t over 100. Look at it. Let's just do it as a sketch. Now assume I want to solve it different from using this formula. I want to still retain this formula. What would I do? I will say 2 pi ft is equal to, what's it equal to? Is equal to pi t over 0.1. Is equals pi t over 0.1. So pi takes off pi, t takes off t. What are we left with? To cross multiply this, you have 2 times f times 0.1 is equal to 1. So my f will now be equal to 1 over 2 times 0.1, which then as 1 over 0.2, which is the same thing as 5. You see that is equal to what we have here. So you can actually use this same formula to solve even if the expression is given like
Now we're
this.
looking at another example, and this time the question is calculate the wave speed. Now remember, to calculate for the wave speed, you have to first look for your frequency, then later on you look for your wavelength, then you cannot use the equation V equals F lambda to solve for your wave speed, but that is a waste of time. What do you need to do? Remember, I just said that wave speed is equal to W over K, which is angular frequency over wave number. So now what do you need to do here is to look for which of them is W and which of them is K. Now remember, from the equation, Y is equal to A sine open bracket WT plus or minus KX. So it means W, which is your angular frequency, is always to T, while K, which is your wave number, is always with X. So there was an interchange of position. There was a change of position. So now you know that this is now your W, while this is your K. So solve this, I will say V is equal to, what's my W? My W is 4 over, what's my K? My K is 3. So this would have been 1.33 meter per second. Now, you would have said, are you sure that what has been solved is correct? Yes, very correct, because if I want to solve this part now, I have to first of all solve for my lambda from here, and I have to solve for my frequency from here, but that is a waste of time. This will just give you the answer, and that's correct. Okay, I'll be looking at more questions, and the questions are: number one, we're looking at a question referring us back to particles in phase and particles out of phase. Now, for instance, the question said, is an SSC question 2018. Which of the points are 180 degrees out of phase? Remember, we said in our early videos, you go check those videos, that a particle is said to be in phase with another particle when they are occupying similar position and they are heading towards similar direction. And the angle between two such particles is always 360 degrees. So for instance, this point, although looks similar with this point, but the particle here is going up and the particle here is coming down. So these 2 points are not in phase. The particle here and the particle here, they are not in phase. But if you compare this to this point and this point looks alike. The particle here is going up and the particle here is also going up. Hence, they are occupying similar position and they are heading in similar direction. So it means that this particle and this particle is in phase. And if you check the angle, remember we said that one curve is 180 degrees, one curve is 180 degrees. So a complete circle is this. So this is 360 degrees. 180 plus 180. If you remember in our last video, I said something like this, where we said that here to this is 0 degrees, this is 180 degrees, while this is 360 degrees. So this place will be 90, while here will be 270 degrees. So also you can check out this particle here is not in phase with this particle, because at this point the particle is at the crest, but at this point the particle is at the trough. They are not occupying similar positions. But if you compare D and F, you see that they are occupying similar position, crest, crest, and they are heading in a similar direction, which means B and F, they are in phase. So A and E are in phase. The angle between them is 360 degrees. B and F are in phase. The angle between them is 360 degrees. C and G are in phase. D and H are in phase. So now let's come to our question. Which of the points are 180 degrees out of phase? A, A and E. A and E, both of them are in phase. B, B and D, B and D. There is a problem here. B ought to be in phase with F. So B to F is 360 degrees. I believe if we take a dotted line out here, you see that this is the half of here to here. This is half here to here. So it means that B and D are not in phase and the half of 360 degrees is 180 degrees. Let's leave the option B. We know they are not in phase. Let's see option C. C and F. C and F. They are also not in phase. But the angle at which they are not in phase is not 180 degrees. These two are not in phase. Let's see option D. D and H. D and H are in phase. These guys are in phase. These guys are in phase. These two guys are not in phase. So now the question is, which of them is 180 degrees out of phase? Now remember, here to here is 90 degrees. 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 Here to here is 90. So in every half a circle, we have 290 degrees, which equals 180 degrees. In every one circle, we have 490 degrees. 1, 2, 3, 4, which makes it 360 degrees. So let's watch now. Option C is saying C and F. How many degrees out of phase? 90 plus another 90, 180 plus another 90, which is now 270. It's not 180 degrees out of phase. But let's see option B. B and D, which is B and D, which is 90, another 90, which is 180. So the right answer for this question is B. B and D are 180 degrees out of phase. Look at question number 2. Question number 2 says, deduce the frequency from this wave. It is wrong to just go straight and say frequency equals 1 over period and say equals 1 over 0.25. That's a wrong step and it's a wrong direction to solve. What is the right way to solve? The right way to solve this is that you should know that frequency equals number of circle or number of oscillation over time taken. Number of circle over number of oscillation, number of circle or number of revolution or number of oscillation over time taken. Now, what is the number of circle in this diagram? One cup, one cup, one circle, another cup, another cup, another circle, and just one cup. So it means we have 2.5 circle. That's 2.5 circles. So that means my number of oscillation is 2.5 over what is the time it took? It took 0.25. So to solve this, it becomes this. So it's now 250 over 25. The answer to this is 10 hertz. 10 hertz is the right answer and not 1 over 0.25, which would have been just 4 hertz. And mind you, there is a 4 hertz in the option and there is a 10 hertz in the option. But the right answer to this question is 10 hertz. Now look at the last question we have here. It says a progressive wave has a wavelength of 50 centimeter. Calculate the phase difference. Phase difference. Phase difference. Now remember when we said y is equal to a sine open bracket wt plus or minus ks. We said kx is phase difference. Now if kx is phase difference, it means that kx is equals phase difference, which equals 2 pi over lambda x. So this is the formula to solve for phase difference. Now, if we have that as a formula to solve for phase difference, it means I will say phase difference, which is phi, is equal to 2 pi times what is our distance between them? Our distance between them is 20 centimeter. 20 centimeter. Depending on the options you have, I could have well convert to meters, but because it's centimeter, I could just let it fly. 20 centimeter over what is the wavelength? The wavelength of the question is 50 centimeters. So if there was a centimeter here and I have a 50 centimeter here, centimeter will take off centimeter. So I have 0 takes off 0 and my answer will be 4 pi over 5. That's how it was in the question that was given. So 4 pi over 5 is the correct answer. Thank you.